Welcome to the Explainer. Today, we're pulling back the curtain on a really complex AI system called KickLang. We're going to look at the blueprint of how it actually, how it thinks. So let's just start with a big question, right? Imagine you have all these brilliant individual components, all these smart little pieces of an AI. How do you get them to work together to create a symphony instead of just a bunch of noise? How do you get that perfect harmony? Well, the sources we're digging into have a really elegant solution. They say, stop thinking about it like a machine. Instead, picture the KickLang architecture as a professional orchestra. Yeah, an orchestra where every single part knows its role and plays it perfectly in concert with everyone else. So let's dive into that. This whole orchestra analogy, it's really the key to unlocking how KickLang manages to pull off these super complex tasks and create something that's, coherent and intelligent. All right. First things first, how does this whole thing even start? It kicks off with us, with a person. We're going to look at how our normal, everyday language gets turned into something a machine can actually understand and act on. Okay, so the first instrument in our orchestra, if you will, is the KickLang translator. Think of it as the bridge. Its whole job is to take a question that you or I would ask, just in plain English, and turn it into a structured, formal command that the system can actually work with. And the process is pretty simple, really. Step 1, you ask a question. Step 2, the translator gets to work. And step 3, boom, you get a precise action plan. This is where your words, your simple question, get turned into a concrete set of instructions. It's basically the sheet music for the entire orchestra. Okay, so we've got the sheet music. Now, who's gonna play the notes? This is where we meet the actual musicians of the system. These are the atomic units of thought. The sources call them Task-Agnostic Steps, or TAS for short. Just think of them as these basic, fundamental building blocks, little cognitive actions that can be reused for anything. And they're all managed by something called the TAS Engine. Each one is like a single, pure skill, like a violinist who can play a perfect C-sharp every single time. Yeah, this quote here really hits the nail on the head. The TAS engine provides the bricks, or the atomic cognitive units needed to get the job done. In our orchestra, these are the musicians themselves. Every single one is a master of their instrument, just waiting for the signal to play their part. So, okay, we've got our virtuoso musicians, but a bunch of amazing musicians playing whatever they want is just chaos, right? How do you get them to play together? You need a conductor. And this is where we get to the art of coordination. This is the real secret sauce of the whole system. And here's how it breaks down. The TAS engine, that's the what. It provides the individual skills, the musicians with their instruments. But the layered cognition processor, that's the how. It's all about the blueprint, the timing, the sequence. It's the conductor at the podium, turning all those individual notes into one incredible symphony. Now, this conductor, the processor, has a couple of really big jobs. First up is something called layered cognition. A huge part of this is cognitive zooming. I love that term. It's the ability to zoom way out to see the big picture, the main goal, and then zoom right back into the tiniest, most granular detail. And this is so important. It keeps the AI from getting lost in the weeds, It makes sure everything, your goal, the plan, the right skills, is all perfectly aligned, whether the task is super simple or ridiculously complex. And its second job is just as critical. It's called meta-temporal coordination. That's a mouthful, but it's really just about one thing: timing. Perfect timing. It makes sure every single action happens in exactly the right order at exactly the right moment. This gives you these smooth transitions between steps so the system never stalls, never loses its place, never misses a beat. It's like the conductor's baton, keeping perfect time for everyone. Okay, but here's the really cool part. This whole orchestra, it's not static. It doesn't just play the same song over and over. This architecture is built from the ground up to learn, to evolve, to get better with every single performance. So how does it do that? Well, for one, it's modular. That means you can update one section of the orchestra, say the violins, without messing with the whole thing. There's a version control system that keeps track of all these improvements. And it has these automated feedback loops. It's basically listening to its own recordings, benchmarking its performance, and figuring out how to get even better next time. It's constantly refining itself. And what this all means is that the system's cognitive kernel, its core brain, its ability to think and coordinate, it actually evolves. It gets smarter, more sophisticated, it gets way more efficient at handling really complex, nested plans over time. Simply put, the orchestra just keeps getting better and better. Which brings us to a final, pretty mind-blowing thought, doesn't it? What we're looking at here is a blueprint for machine thought, one that's structured just like a beautiful, complex piece of music. So if this is the score for today, what incredible symphony is it going to play for us tomorrow?